Dear students, today we are discussing about some redundancy properties of a reliability system. Okay, you might have seen that or heard that in aeroplane, the engines of aeroplanes. Okay, there are two or three engines for aeroplanes. Yeah, these are some working engines of aeroplanes. We will have at least two engines in at least two or three engines are actively working when a flight goes. Okay, so some two or three engines will be available. And what is the need of uh, putting two or three engines in the aeroplane? Okay, it is a risky job to fly aeroplane through the air. Okay, moreover, in laboratories you can see there are 6 or 10 systems, computer systems, or there will be or 3 or 4 batteries. The required required number of system will be maybe any 6 or 7, but you will keep 10 or 12 systems in your lab. Okay, and also you will keep 2 or more pen for your examination hall. When you go to the examination, you will keep at least 2 or 3 pens. What is the need of taking 2 or 3 pens in your pocket? What is the need? Yeah, the idea is if any one of the pen is going out, then you can use the other. Okay, otherwise you can in for example, in a computer system, either you can keep 2 or more computers or extra for your computer examination. Okay, you can keep a number of systems as a spare for the functioning of the entire system. Okay, so what is the need of keeping that spare or connecting the system as a as a parallel system? What is the need of applying that principle in our daily life? How you think about that? Let us look another system, that is uh, pipeline. Have you seen the images of oil transportation systems? Yeah, sometimes you can see it like this. In Gulf countries, you can see the oil transportation system like this. There are two number of pipes are there, two pipes are there, and you can see, yeah, uh, several pipes are going like this parallelly. Okay, yeah, you can see number of pipes are going like this. This is oil transportation system. Power generation system. Hmm? Another is nuclear power generation. Nuclear power generation. Have you seen that? Yeah, you can see two systems, two components are connected. So in aeroplane, nuclear power system, or pipeline system, or computer lab, etc., you can see uh, a number of systems are connected in series or in parallel. Okay, there are a number of computers connected series or in parallel. So what is the use of, what is the need of connecting this theory? So there is a theory behind this idea. There is a theory behind you're keeping some 2 or 3 pens in your pockets when you go to the examination hall. There is a theory behind that. The theory is coming from the reliability concept. Okay. So at the same time, you can say that instead of keeping 2 planes, we can keep 2 engines. Okay. At the same time, when we go to a computer lab, you will keep 2 systems, but not two monitors or two what is that, SMPs or 2 UPS. You will keep 2 systems. So that will depend upon the what is that, cost for preparation of this type of parallel connection. So in the case of plane, you will not keep 2 planes parallelly. At the same time, you will keep 2 or 3 engines parallelly in the plane. Okay. So what is the need of keeping this type of components parallelly, system parallelly? So it will depends upon the requirement. For critical systems, according to the convenience, you will keep either components in parallel or series, or system itself in parallel or series. So that will depends upon the cost, requirement, etc. Okay. The let us denote two vector notations, that is x union y. What is x union y? What is x union y? X union y, that equal to x1 union y1 comma etc. xn union yn. This is a vector. This is also vector. This is not a, it's a variable. Union means is for parallel connection. Okay. y1 okay, this is one notation. And we can also consider another notation, that is x dot y, that is x1 into x2 etc. xn into, okay, that are the two notations we have used. And we shall prove one theorem. Theorem says that phi of x union y greater than or equal to phi of x union phi of y. And second part, phi of x into y less than or equal to phi of x into phi of y. Okay, so we have to prove that phi of, what we have to prove? Yeah, we have to prove that phi of x union phi of x union y is greater than or equal to phi of x union phi of y. We have to use the vector notation. Here also we have to use vector notation. Here also we have to use vector notation. Here also we have to use vector notation. So this is the first result we have to prove. Okay, phi of x union y greater than or equal to phi of x phi of. This is component wise parallel connection. This means we are connecting parallel spare components in parallel to each component. Okay, the spare is connected to nth for the nth component. The spare yn is connected to connected with xn parallelly. Okay, so this is component wise redundancy. This is called component wise redundancy. Okay, so but this means one system is connected with the spare system parallelly. This is system wise redundancy. Okay, system wise redundancy. You can consider component wise redundancy as well as system wise redundancy. Okay, this is actually component wise redundancy. So which is better? Yeah, when we connect component wise redundancy, when we apply component redundancy, that will be better. That will be better than system wise redundancy. Component wise redundancy will be better than system wise redundancy. Okay, that is the reason for connecting aeroplane, connecting two engines for aeroplane. Okay, or you are keeping two pens with you. Okay, so the system wise redundancy is less what is that? It is not good as the component wise redundancy concept. Okay, so we have to keep the spare by what is that? We have to apply spare to components. Then that will be better than applying spare systems. Okay, so that will be proved by usual mathematical analysis. Let us consider table 1 2 3 4. Okay, let us consider this is state of ith component, this is state of ith component, this is xi union yi. Okay, only 3 columns are required. Suppose this is 1 and this is 1. What happens? This will be also 1. Suppose this is 1 and this is 0. Then what will be union? Yeah, it is parallel. X and y are connected in parallel, so it will be 1. This is 0 and this is 1. So again the parallel system will be in working condition, so it is 1. So it is 0 and it is 0, then the parallel system will be in failed state. Okay, so now let us consider now we move to the yeah, that in this case we can say that xi union yi is greater than or equal to xi. Yeah, that is look at this is xi union yi. Okay, this is greater than or equal to 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 xi. Is it right? Oh, yi. What is the reason? Xi union yi, that is 1. 1 is greater than or equal to 1. Okay. Here xi union yi is 1. 1 is greater than or equal to 1. Here xi union y is equal to 1. That is greater than or equal to 0. Xi union y is greater than 0. It is greater than or equal to. So we can say that xi union yi greater than or equal to xi. Similarly, xi union yi greater than or equal to yi. Okay, xi union yi greater than or equal to yi. So this is the situation. Okay, so this is the situation. Okay, you got the idea. I think you got the idea. So now we can formalize this. You know that phi is coherent. What is coherent means? Coherent means all components are relevant and phi is increasing. Function is increasing. We are considering coherent system, so phi will be increasing. So what happens? Yeah, we can apply phi here. So what will be the result? What will be the result? Yeah, insert phi of x1 union y1 comma etc. Greater than or equal to phi of x 1 comma etc. xn. Similarly, we can apply this for xi greater than ya. In this case, we will have phi of x1 union y1 comma etc. xn union yn greater than or equal to phi of y1 comma etc. yn. Okay, simultaneously using this result we can express like this. So this can be again written as or okay, or simultaneously we can write as y1 or what is that, phi of x1 comma etc. comma xn. Okay, these two equations are simultaneously like this. I think you got the idea. Then the or can be replaced as, in the case of binary system, or means it is parallel. Okay, x or y, x union y, so it can be replaced by union. Okay, so that is the result. That is the result. Phi of x union y greater than or equal to phi of x union. So this can be obtained. Or again we can what is that, write like this. This can be also written as maximum. Okay, can be also written as maximum. Maximum instead of 4 we can put comma here. Maximum of this one. Okay. So this is the result. So connecting component wise parallel, you can ensure more reliable system. Instead of putting another system parallel, we can put components in parallel, so that will create more reliable system. Okay, that will be more reliable or more what is that, better than the system wise redundancy. So component wise redundancy is better than system wise redundancy. That is the idea. So that principle is applied in all reliability control, transportation, nuclear power system, computer lab, engines, etc. Everywhere you can see this concept. Okay. Another is phi of x dot y less than or equal to phi of x into phi of y. How can we analyze that? Yeah, I will insert one more column to the right. So what is the value of this column? xi into yi. Okay, what is the value? This is 1, this is 0, this is 0, this is again 0. Okay, so look at these values. xi yi value is less than or equal to xi, or xi yi value is less than or equal to yi, and 0 is less than or equal to 1 and 0 less than or equal to 0. That means xi yi value is less than or equal to xi and simultaneously yi. Again xi yi value is 0, then that is less than or equal to xi and that is less than or equal to yi. Okay, in the last case we can easily see that. So how can we express this? Xi dot yi, this is less than or equal to xi, or xi dot yi is less than or equal to yi. So very simple. In that case, how can we analyze? Yeah, since phi is coherent, we can apply the what is that, coherent and increasing. So we can apply to the coherent system. So what will be the result we are obtaining? Yeah, x1 y1 into y into etc. xn yn will be less than or equal to, since it is increasing, function is increasing, so smaller will be value will be having smaller value for the function, and higher value will be having higher value for the function. Similarly, we can write in terms of yi. Okay. So simultaneously, the left side is less than or equal to phi of x1 xn, and left side is less than or equal to phi of y1 y2 etc. yn. So in that case, we can write like this. This is this is and phi of can you say that phi of y1 comma etc. yn. Okay, that is this will be less than or equal to minimum of this one. Okay, simultaneously phi of x1 into y1 etc. xn into yn is less than or equal to phi of x1 xn and y1. So instead of writing like this, we can write as this is less than or equal to minimum of this and this comma this, minimum of phi of x1 xn comma phi of y1 y2 etc. yn. Okay, so the what is the minimum in terms of binary system? What is minimum? Minimum is for the series system. So we can, instead of minimum, we can write the product. Okay, minimum for series system, structure function series system. So structure function series system can be written as product. Okay, so just remove this one and we can put the dot here. Okay, so this is exactly the second result. What is the second result? Yeah, instead of so what is the second result? Phi of x dot y less than or equal to phi of x into phi of y. Okay, I think you got the idea. These are the steps. I will share you this concept. So when the components, pair components are connected in series, not in parallel, where the pair components are connected in series, so it is better to keep the system itself as series, as a what is it? It is better to connect the system as series for the better performance. Okay, if we keep the system as a series, if we have a spare system, and if we put the system, if we put the spare as a series, it is better than connecting the components in series. Connecting the system in series is better than connecting the components in series. The performance of the whole system will be better when it connect in series. When we connect the spare in series, in system wise, that will be better than connecting the components in series. Okay, so instead of if we have some spare components and if we have some spare system, the performance of the system including the spare, so the system wise performance will be better than the component wise performance in the series concept. Okay, so instead of keeping the spare components in series, we can keep the system as a spare, but sometimes we cannot ensure this this theory in the case of aeroplanes, because we cannot keep spare to the aeroplanes, so that is not possible. At the same time, you can keep the components of the aeroplane. Okay, so sometimes that is not possible. So if the components are connected in series, if the spare components are connected in series, so it will have less performance than if the system is connected in series. Okay, so you think about that idea and you will get more information from the book of Balan Prosen. Yeah, from this book. Okay, so this is these two lines we have discussed here. For the proof of P, we have used the steps in the word format. You can write down that, no problem. Anyway, you think about these ideas and you write down these materials in your notebook. Okay, and as a seminar, you can see that as a special case, when we select a series system or when we select a parallel system, you will get special cases. The equality holds in A. Equality holds in A. Equality holds in A for all x and y if and only if the structure is parallel. If the structure is parallel, then the equality holds for the A part. So equality holds in B part if and only if the structure is series. If the structure is series, then equality holds in B. So that can be proved by any one of you and discuss as a seminar. Okay, if the system is series, phi of x dot y equal to product, the first one step is given here. Okay, the case of parallel, you have to discuss that. So this special case can be discussed by any one of you, no problem. Okay, so I think you got the idea of this result. Keeping the components in series will reduce the performance of the system than keeping the system with that components in parallel. Okay, suppose you have one UPS, one CPU, one you have a spare of each and every component. You can make a system as a whole, so that you can make two systems. So you can connect that two system in series. That will induce more performance. That will ensure more performance. Okay, instead of keeping the components in series, you can keep the system in series. Okay, so that is the idea. So we got the idea. I think this is redundancy concept. First one is redundancy concept. Another is the concept behind keeping the system in series, system as series, instead of keeping the components component wise. what is that, components are in series, spare components are in series with the original components. So the idea coming from this results. Okay. You may study this concept and write down and submit in the Moodle.